Greetings and welcome to Zord's Asteroid Space Program Episode 9, where we are going after the E-Class asteroid. We have a fully capable ship in orbit and we have a maneuver node planned out. Now all we have to do is execute this maneuver. We are going to add a couple of 100 meters per second to get us out in an orbit beyond Minmus. Unfortunately, with 4 nuclear engines and hundreds of tons of fuel, we can only add so much delta V per orbit. So this is, of course, just like last time, going to be a multi-burn maneuver. So you have several increasingly larger orbits, one after the other. Fortunately, this is not a problem, as the asteroid is still far out and I can just adjust later on what I do and still have a good encounter. Now I have planned out all the separate small little burns, as I now know how much delta V I can add per orbit. So now we really just have to do the pattern. We don't have to reconfigure the nodes every single time. This is quite a fair bit later. We have done all but one of the passes and we lost contact with the asteroid. There we are. We just have to do this one last burn and we should be on a orbit to the maneuver node, which will bring us to the asteroid. And as you see, the target asteroid is still outside Kerbin's sphere of influence, and that's good because going out to the apoapsis of the biggest orbit takes quite a lot of time. There we go. Now we have our large orbit. Now we just have to trim the final node to get us our encounter, and this takes, of course, quite a while. It's a very sensitive maneuver node because you are planning something far ahead, and a very small correction in that end gives you a very large effect on the other end. And here we see the asteroid predicted path glitching about. I thought this was as it's been always, graphical glitches in how the orbit is showing, but doesn't actually affect gameplay. Fast forwarding through this rather large maneuver node, made a lot smaller by the distance from Kerbin, we can see the results of this glitching the asteroid did. Because the projected path for the asteroid is not at all what it was when I set up my maneuvers. And it's not just a little glitchy thing, it's way off. So I reload and try to do it again, try to figure out why this happened, because this is not an error on my part, quite obviously. This is something the game did. And we can see here, when you switch to the highest time acceleration, the projected path for the asteroid just change. It's something else, and the encounter no longer fits. You see, the asteroid is the encounter. It's moving when you are time warping. Fortunately, this time I did very little time warping, so we can just correct this with the maneuver. But still, it's a bit annoying that this would happen, especially since Squad did change the system for crossing into spheres of influence, so that it would be less problems with crossing spheres of influence under time warp. It sadly appears they did not completely nail it for at least the highest time warps. So we're doing this nice time lapse of the maneuver again. This time it does result in an encounter with the asteroid, which is really good. And from here we just have to sit and wait for the asteroid to come close. We will of course want to trim this maneuver or this encounter so that we are sure we actually end up close enough. And then we want to have an idea what kind of maneuver and how big it is we have to do when we get there. So I set that up a little bit, and now we warp a lot. This mission has been going on for quite a while, and we are not even at the asteroid yet. Fortunately for us, it's just waiting. Unfortunately for the astronauts, it is very much just waiting. So we're approaching the asteroid and the subsequent maneuver to match orbit, and yeah, we can notice a problem here. Due to the low acceleration of the Artemis, we have to start the maneuver so far out. Our orbit is deformed and it will not end up being exactly the same as the orbit projected from the maneuver node, as the maneuver node assumes instantaneous change. The second problem, as we see here, is that the acceleration is indeed so low we can't really perform the maneuver node. We're just sailing past the asteroid. But I'm not gonna let that stop me. Just keep burning and we will eventually somewhat match the orbits. Now we are both on an escape trajectory. This is a significant amount of time later, and I'm just trying to get the orbits to cross so that we will eventually get kinda close to each other. So now the orbits are crossing in all planes, and here we have to sit and wait. I severely hope that we are gonna get close to the asteroid, as the encounter system isn't cooperating anymore. We are both on an escape trajectory, thus we will encounter each other in the solar orbit, it says. I disagree. I am indeed quite close to the asteroid now. From here we can start doing manual adjustments, or rather, we're not looking at the projected paths as much as we're looking at the relative velocity and direction. Or rather, just our relative velocity, since velocity is a vector quantity which involves both speed, which is the magnitude of our movement, and the direction of our movement. So here we are. This asteroid is quite large, not as large as I remembered it or expected it to be, but it could be a small sample of the E-class asteroids. Regardless, we are here. We now have to grab it. And we have learned since previous that it's probably easiest to align the ship with the direction you want to pull it and then grab the asteroid. So that's exactly what I'm going to do. So here I have aligned the ship with the orbit retrograde marker, and now we have to maneuver this large ship to grab the asteroid. The Artemis looks very good in this light from this angle, and with the RCS thrusters firing, it looks like a proper deep space ship, even though it's quite simple in my mind. It's a rather simple ship with a simple purpose. So now we're getting ahead of the asteroid, illuminating it with our very bright lights. Let's tone it down a bit and cut forward to the actual final approach. Here we of course have to be very careful, grabbing this very massive object with the somewhat unwieldy Artemis. There we go, solid lock. Now we should just, okay, this isn't very effective, but we should try to align with the center of mass. And now of course we send out these 8 fuel tank things to attach at various points of the asteroid. Just like before, this is the same drill, or rather, this is the actual thing we practiced before. You fly them out to 8 evenly spaced positions around the asteroid and grab it. Okay, let's try to, there we go. And then we repeat this 8 times. This is the last one, and right before I attach, I accidentally hit spacebar and eject the fuel tank that's attached to it. Fortunately, that fuel tank was completely empty. So we didn't lose any fuel, we only lost some dead weight. So I decided, for symmetry's sake, to eject the one opposite to it as well. So there we go, we lost maybe 10 tons of just useless matter. And yeah, overall good. So now we should be able to bring it home. It has apparently rotated quite a bit while I was attaching these fuel tanks. It's entirely possible that there's some phantom forces invoking some strange rotation on this thing. And of course we're not entirely balanced, so it's a bit of work trying to get this to move in a straight line. But we are indeed moving. We are not putting in insignificant amount of delta V to this space rock, and we are indeed bringing its apoapsis down within the sphere of influence of Kerbin. And really, we don't really care about the precision of where exactly we end up, how our orbit looks, as long as it is not escaping. So we really just have to slow down at this point. We actually want just to have a apoapse that we can arrive at and adjust our periapse. Because at present we don't have an apoapsis. Or well, maybe we do now, I'm just trying to bring it down so we get there within our lifetime. But as you see, yeah, this is fairly stable and it's fairly effective. You can even use a lot of thrust, even though now we are veering very much of course. But we have an apoapse, we have closed orbit. So now we just have to do some minor adjustments. Whoa, you see that? The orbit rocked. Nothing broke, so we're good. Just the physics. I'm not really happy with the way I have constructed this, I suppose. Yeah, we are bringing the periapses down. We're going to do an aerobraking. Can save a lot of fuel this way. We have positively impolite amounts of fuel left. This is this mission was way cheaper than I expected it to be because of the asteroid's low periapse. And that's very good. You know, when you think about it, the faster an object moves, that is, the lower its apoapsis, while it's on an escape trajectory, the less energy it has. Think about it. It's true. So we are aerobraking and slowing down and burning, maybe not really burning up, but we are certainly burning. Fortunately, nothing takes damage ever from being on fire. You know, metal explodes, but nothing burns, so that makes sense. Okay, so we are at our apoapsis. We forgot, or I forgot, to take a surface sample of this thing while in high orbit. Fortunately, this counts as high orbit, so we got that sample. Good. We don't get a lot of science, but we should at least take what little we get. Now we need to raise our periapsis, and then we have a stable, if not very pretty, orbit. So that's what I'm gonna do. We turn the ship around, takes a bit of time, but skip that, of course, for your convenience. So now we are raising the periapsis, and bringing the orbit circular maybe is something you should do, but at this point I don't feel like we have time for it in this episode, or maybe I have time for it at all. So I will just thank you for watching, and I hope to see you next week. Goodbye!